Okay, scaling principles for volume. We're going to continue to work with volume, but in this case, we need to pay attention to the scaling principles. This opening exercise, I'm going to skip, and we're going to look directly at problem number 2. We are looking at page 132. 132. And they asked us to find the volume of each of these. And this is interesting because they didn't give us numbers, they gave us letters. But we know that the formula for this, volume equals length times width times height. Therefore, the volume here is A times B times C. And we're going to call that volume 1. Volume 2 is going to be equal to 2A times 2B times 2C. Which is equal to 8A BC. Volume 3 is equal to 3A, 3B, 3C, or 27A, B, C. And the last one, volume 4, when you multiply 4 times 4, you get 64 A, B, C. And you're supposed to pay attention to the fact that that's 2 cubed, 3 cubed, 4 cubed, and so on. And you're looking at the fact that volume is cubic, and we're looking for relationships in these. So they want to make sure you get it. They're asking you to go ahead and work all of these. So stop the video and go through each one, see how you do. Okay, so as you go through this, the first one was 1/3, 8/3, 27/3, 64/3, 125/3, and notice that the volume goes up by a cubic each time. All right, so if two solids are similar and their corresponding sides are A to B, the ratios of their volumes is A cubed to B cubed. So, ratio of the length of the sides, if these are similar, and that's what they're stating, these are similar figures. So the ratios of the sides here, big to smaller, A to B, we're going to stay with A to B each time, is 5 to 4. The ratios of their volumes is going to be 125 to 64. A to B goes, and I'm going to choose the smaller of the numbers here, 1 to 5. And the volume is going to be 1 to 125. Number 7, looking for the smaller of the two. This is going to be 6 over 18. That reduces, and you can always reduce 1/3. The ratio of the volume then is going to be 1 to 27. And that would work out the same way if you use 6 over 18 and you cube those. They just give you bigger numbers. And obviously bigger numbers are harder to deal with. All right, so we're going to go 3 to 2, which is cubed is going to be 27 to 8. And lastly, 2 to 20 reduces to 1/10. Ratios of the volume is going to be 1 over 1,000. That's the whole concept that we're trying to get at, you guys. Now, we go a little further. It says use the triangular prism shown below to answer the questions that follow. Calculate the volume of the triangle. Well, the volume is equal to area of the base times the height. This is not a cone or a pyramid. It's a prism. So that's 1/2 times 3 times 3 times the height is 5, or 45 halves, and this is units cubed, whatever that is. Okay. If one of the sides of the triangle base is scaled by a factor of 2, the others by 4 and the height is 3, you now have a triangular prism. And I got a little excited with that, so we're going to have to erase that much of it, right? So 6, 12, and the height now is going to be times 3. 3 times 5 is 15. The volume now is equal to 1/2 times 6 times 12 times 15. And if you plug that puppy into a calculator, hopefully you end up with, where is it, 540 units cubed. All right. The next question here says, complete the statement. The volume of the scaled figure is equal to the volume of the original figure multiplied by something. Now, my conjecture is here that if I take 45 halves and I multiply them by all those scale factors, 2 times 4 times 3, that I will end up with 540 units cubed. Check that out, make sure I'm right. And then down here this says, complete the statement below is multiplied by the scale factors of the scaled factors, or the product of the scale factors, right? Here's the product that they were talking about. Okay, so this last concept was not as important as the basic idea, you guys. We've seen this before. If you have the ratio of the sides is, say, 2 to 3, then we know the ratio of the areas is going to be 4 to 9. And now we figured out that the ratio of the volumes is going to be 8 to 27. Okay, so if you are given 1, you should be able to go back to that and then go to the volumes and work that a number of different ways. Good luck.